In Module 1, we're looking at absolute value equations and inequalities. But before we do that, we're going to start with Section 1 where we review solving linear equations. So a linear equation is when you solve a linear equation, you find a value for an unknown variable that makes the equation true. And there are various levels of difficulty for solving a linear equation. The most basic form is solving using the addition property of equality. And that states that an equation is still equal when adding or subtracting, considering that's just adding a negative number, the same value to both sides. So let's do a couple examples where we use the addition property of equality. So our first example, we have x minus 3 equals 11. So we're going to do the opposite of what's with our variable to solve for it. So we're going to add 3 to both sides, which gives us that x equals 14. And we can always check our answer by plugging 14 in for x and making sure that 14 minus 3 is 11, which it is. Our second example is x plus 3 equals 11. So the opposite of addition is subtraction. So we're going to subtract 3 from each side, and we get that x equals 8, which again we can check by plugging 8 in for x and checking that 8 plus 3 is 11, which it is. Next, we have the multiplication property of equality, which states that an equation is still equal when multiplying or dividing the same value to both sides. So our first example says that 4x equals 20. So because there is multiplication in front of our variable x, we're going to divide both sides by 4. And we get that x equals 5. Our second example says 14 equals negative y. So to get rid of the negative in front of y, we're going to divide both sides by negative 1. And we're going to get that y is negative 14. And our last example, we have k over 4 equals 4/7. So I'm currently dividing my variable by 4. So I'm going to multiply both sides by 4. Now when I multiply the right side by 4, I'm technically multiplying by 4 over 1. So we're going to get k equals, and I do 4 times 4, which is 16, over, and then 7 times 1 stays 7. So we get k equals 16 over 7. We also have examples that combine both of those equalities. So when we have a combination of our equalities, we always start with the addition or subtraction equality first. So 3x plus 6 equals 12. My first step is going to be to subtract 6 from both sides. So we end up with 3x equals 6. Then we're going to divide both sides by 3, and we get x equals 2. And in every example we do, we can always check our answer by plugging the value we get for x back into our original equation. Our second example, 4 parentheses x minus 2 equals 6x minus 10, before we can actually solve, the first thing I have to do is take care of that 4 that's in front by distributing it into the parentheses. So we're going to end up with 4x minus 8 equals 6x minus 10. Now, in this case, when I'm solving for x, I need to work on getting the x's on the same side of the equation and then moving the constants over to the same sides. And it does not matter with what you start with first, whether it's moving the variable or moving the constant. I'm going to start by subtracting 4x from both sides. So I get negative 8 equals 2x minus 10. I always like to solve so that I'm keeping my variable positive instead of negative. Next, I'm going to move the 10 by adding 10 to both sides. I'm going to get 2 equals 2x, and then my last step is going to be to divide by 2, so we get that x equals 1. We're also going to talk about equations that have fractions, and we're going to talk about later how to solve equations with fractions, but for right now, we're going to talk about how to clear those fractions with something called the LCD. So remember, LCD stands for least common denominator. So what that means, it's the smallest value that when I multiply everything by the LCD gets rid of the fraction. So what we do is we multiply the equation by the LCD to clear our fractions. So our first example, we have 4/3 x minus 7/4 equals negative 5/4. So our denominators are 3 and a 4. So I need to find the smallest value that 3 and 4 both go into. And in this case, the LCD is 12. So we're going to multiply all of our fractions by 12. So when I do 12 times 4/3, what I like to do first is divide by the denominator before I multiply. So 12 divided by 3 is 4. What leaves us with 4 times 4x minus, and then 12 divided by 4 is 3. 3 times 7 equals negative, and then 12 divided by 4 is still 3, which is 5 times 3. Now I'm going to multiply, so I get 16x minus 21 equals negative 15. Now I can use the addition and multiplication equalities to solve. So I'm going to add 21 to both sides. So I get 16x equals 5. Then I divide both sides by 16. And I'm going to get x equals 5/16. We are going to leave our answers as fractions for the time being. That way our answer is exact and it's not an estimation. Our second example, 3n plus 5 all over 2 equals 4 plus 4n plus 2 all over 4. Just to refresh, the 4 is technically 4 over 1. So we have denominators of 2, 1, and 4. So the smallest number that 2, 1, and 4 all go into is 4. So it is okay for your LCD to actually be one of your denominators. So now I'm going to multiply every fraction by 4. So 4 divided by 2 leaves me with 2, and it is important that in this case, 2 is multiplied by all of the numerator 3n plus 5 equals 4 times 4, because 4 divided by 1 is still 4, plus, and in this case, 4 divided by 4 is 1, so I don't have to put parentheses around 4n plus 2. So I am going to distribute the 2 into the parentheses, so we get 6n plus 4 equals 16 plus 4n plus 2. I have like terms on the right side, so 6n plus 4 equals 18 plus 4n. So now I'm going to start solving for n. So I'm going to subtract 4n from both sides. So we get 2n plus 4 equals 18. I'm going to subtract 4 from both sides. We get 2n equals 14, and last step, divide by 2, and we get that n equals 7. The last thing we're going to talk about are special solutions. So that's when you get no solution and all real numbers as a solution. So the first one is contradiction. So that's when an equation states that two unequal values are actually equal. So for example, you get something like 3 equals 4, which is a contradiction because 3 does not actually equal 4. And this is the case of no solution. Okay. We also have something called identity. And that's when an equation states that two equal values are actually equal. And for example, that can be something like 7 equals 7. And when this happens, that's when we get the all real numbers as our solution, which would mean that every number that you plug in works. So we're going to take a look at a couple examples. So the first one, we have 4y minus 7y plus 2 equals 9y minus 3 times 4y minus 5. So the first thing I need to do here is take care of distributing. So for my first one, there's technically a negative 1 in front of the parentheses that I'm going to distribute in. That'll give me 4y minus 7y minus 2 equals 9y, and then I'm going to distribute my negative 3. I get minus 12y plus 15. Because remember, when you multiply two negatives, you end up with a positive. Before I start solving for y, I'm actually going to combine like terms. So 4y minus 7y is negative 3y, minus 2 equals, and then 9y minus 12y is negative 3y plus 15. So I'm going to add 3y to both sides, and in this case, when I do that, they end up canceling. And I'm left with negative 2 equals 15, which is not true. So it's a contradiction, which means my answer is no solution. Last example, we have 4 times x plus 2 equals 6x minus 2x minus 5 plus 3. So again, my first step is going to be to distribute. So I get 4x plus 8 equals 6x, and then remember technically a negative 1 in front here, minus 2x plus 5, and then plus 3, because the 3 is not in the parentheses. So I only have like terms to combine on the right. So 6x minus 2x is 4x, and 5 plus 3 is 8. So I'm going to subtract 4x from both sides, and they end up canceling, and I'm left with the statement 8 equals 8, which is true, which means it's an identity, which means my answer is all real numbers. Please let me know if you have any questions about anything we've covered in section 1.